Hello, this is Mrs. Ringrose, and I'm trying to get you excited about quadrilaterals. Sorry that my allergies are kicking in and my voice is going, but let's get started. So we're going to be doing a lot of work with quadrilaterals, and I'm going to try to actually go as quick as you will let me because I feel like a lot of the information is from triangles and we can just transfer that over to quadrilaterals. Here's a nice graphic to show the family. We're going to work on identifying them another day. Some goals for quadrilaterals. All right, so I actually made you do this on a day that I had to be out. So let's see how much you remember. First of all, the Polygon interior angles theorem you learned is that if you take all of the angles and you add them up, it's going to be the n minus 2 times 180. All right, where n is the number of sides. And that'll give you the total interior angle sum for any convex polygon with n number of sides. So think about trying this out with a triangle. If I put 3 in there, because a triangle has 3 sides, I would do 3 minus 2, and I'd get 1, and 1 times 180 is 180 degrees. So it works out. So that is a rule that you're going to have memorized. And then we can use that to get the information for the interior angles of a quadrilateral, and it's always going to be 360. And this is the math involved. You can also think about, whenever I get stuck, because I hate memorizing this kind of rule, if I had a quadrilateral, I can divide this into 2 triangles. So this one is 180, and this one is 180. And then I can go ahead and add those together, get 360. So whenever you have a polygon and you can't remember the rule, just use diagonals to divide it up into a bunch of triangles. So hopefully that'll help you. All right. So that's basically what this video is going to be about, is using the interior angle, and more specifically for quadrilaterals is 360, but we're going to do a couple other types of polygons as well. So we're going to practice that theorem to find the sum of the measure of the interior angles of, so I'm sorry, actually we're going to work it backwards. So we're told in this case that the sum is 900, and we have to find out how many sides it has. So here's my formula, and we're told it totals to 900 degrees. 900 degrees. So I'm going to go ahead and divide out 180. And that's going to be 5. So that means that this must be a polygon with 7 sides, which is called a heptagon. If you remember all your names, I made you do that earlier. Okay. All right. So then we're going to use the theorem to find an unknown in a quadrilateral, which is more like the ones that you're going to be seeing for this unit. So you're going to first notice that this is a quadrilateral. Quadrilaterals total 360 degrees. So I can, just similarly to how we did with triangles, I can take all the angle measures and add them up and set that equal to 360. And I'm sure that you can go ahead and finish solving that correctly, and you should get x equals 72 degrees. So that's an example of using the polygon angle sum theorem for a quadrilateral. All right, number 3. Use the diagram at the right. We're going to find the measure of s and the measure of t. So these are congruent angles because of the arc. So I want to make them both x. And this is a 1, 2, 3, 4, 5. This is a pentagon. So I can calculate this first if I wanted to. It's 180 times 5 minus 2. So 180 times 3 is going to give me 540, I think. I just want to make sure I got that right. Yeah, 540. Yeah, 8 times 3 is 24. Okay. So that's how much all the angles together add up to. So now I'm going to go ahead and set up my equation. Plus 2x's. It totals up to 540, and then you can go ahead and solve for x and find out what those are going to be. Sorry about that. So number 4, we're not given a picture, so maybe that's something I want to do first. But I'm told that the measures of 3 of the angles are 89, 110, and 46. And we're expected to find the 4th one. You may or may not need a picture for this one. I know that quadrilaterals add up to 360. So we're talking x plus the other 3 angles is going to add up to that. And so that's a pretty simple linear equation that I'm sure you can finish up for me. And that's all you're asked to do is find the measure of that 4th angle. Okay, so we've been able to practice using the polygon angle sum theorem with a couple examples. Now we're going to move on to the polygon exterior angles theorem. Now this one is way easy to remember because there's no formula involved. It actually turns out that no matter the size, anytime you have a convex polygon, the sum of exterior angles equals 360 degrees. Crazy, huh? So if you look below the picture below, or actually maybe I can draw one in here for you. So let's see what I can draw here. All right, I got a good little hexagon going. So when we're talking exterior angles, we're talking exterior angles on one side if you draw a line. So like here's an exterior angle, that one, that one, that one, that one, and that one. So all those angles are outside of my hexagon, and those are the angles we're talking about. In a rectangle, you know, think about it. We got a right angle, right angle, right angle, right angle. So all those 90 degrees, they're on the inside, they're also on the outside. It's going to add up to 360. So an application of this sort of problem is if you are asked to find one exterior angle and you're given a diagram such as this, you'll know to total everything up to 360 because all the exterior angles are going to add up to 360. And 360 minus 156 and then divided by 3 is you're going to get x is equal to 68. So on this one it looks like they're just asking you to solve for x. You don't have to go back in and find an angle measure. But if I'd asked you to do that, you would know this one's 68 and then this one would be 2 times 68, right? All right, I think this is the last thing I have for you. And then you're going to come in and do some identification activities with me. Basically this first section, again, is just getting familiar with the polygon interior angle sum and the exterior angle sum. So next, we're told we have a convex hexagon with those exterior angle measures, and what's the 6th one. So we'll label that one x, and we're just going to take all these numbers. So I got 1, 2, 3, 4, 5 angles plus the 6th one because it's a hexagon, and set that equal to 360 because all exterior angles are going to add up to 360, and then you're just going to solve for x. Okay, so I hope this was a good introduction for you on interior and exterior angle sums. Oh, I got one more for you. The regular one. I love this one because there's an extra step. And we want to know interior and exterior. All right, so we have to know what the word regular means in order to solve this. Regular means equilateral And the really important word here, equiangular. That means all the angles are the same. So I can label them all X if I have a picture. And I know that I'm talking about 8 X's. If all the interior angles are the same, that means all the exterior angles are also going to be the same. So let's do exterior first. I know that 8x is going to equal 360 because all the exterior angles is going to be 360. And let's actually call this 8y so I can keep my exterior angles separate from my interior. All right, 360 divided by 8 is 45 degrees. So that actually might be the easy way to go because now I can find the interior by doing 180 minus 45. So all my interior should be 135. But let's solve this a different way by using my interior angle sums just so I can have a lot of practice. So I know my total sum is going to be 180 times 8 minus 2. And 180 times 6. I should have all these memorized by now. Is 1080. So that's the total sum, right? I'm just looking for 1. So how many angles do I have in an octagon? I have 8. So I'm going to have to divide by the number of sides. And hopefully I get 135. I do. 1080 divided by 8 is 135. All right, so we have successfully found the measure of one interior angle and one exterior angle for my regular octagon. Let's see. Okay, that's definitely it. So tomorrow we're going to be doing some identification. You are going to have some homework on this. It's going to be on page 510. So look for that in class. And happy angle measuring.